In this video, we are going to be investigating a bunch of conjectures involving arcs and angles. And I would say this is one of the most involved lessons in chapter 9 and quite possibly even in the whole course. So it's one of those things where you just have to keep working at it and expose yourself to the content. And if you're having difficulty with it, you just keep working at it. And the more you do it, the more you're going to get better at it. I'm just going to skip over the warm-up here. We've already talked about secants. A secant is a line that intersects a circle twice. Remember, a segment can't be a secant. We don't have a secant segment. They're always lines. And if we have a part of a secant, though, that is a chord. And we talked about chords in lesson 9.2. So for this first investigation, we are going to take a look at an inscribed angle. Remember, what is an inscribed angle? It's an angle whose vertex is on the circle and whose sides are chords. So this is our inscribed angle, and I'll give it a couple. So this is angle ABC. That's our inscribed angle. And the intercepted arc is arc AC. And whenever we think about intercepted arcs, here's what I do. If I'm like, what is the intercepted arc? I put each of my pointer fingers on the vertex, and then I trace the sides of the angle. So notice I'm just like pulling my fingers along the sides. And then where my fingers hit, that is the intercepted arc. So arc AC is the intercepted arc of inscribed angle ABC. So that's something that we need to note for this lesson. For this first investigation, they give you the setup and they want you to measure angle COR, which is the central angle. And then we know that angle COR measure is also the measure of arc CR because that is the definition of arc measure. And then we're going to measure angle CAR. So angle CAR is the inscribed angle who also intercepts the same arc as the central angle, angle COR. So we're going to go ahead and measure those two things. If you need to extend some rays, so as I'm like lining this up, I notice this isn't coming out of my protractor properly. So I'm going to extend those rays to get a nice measurement. Lining everything up here. For me, it looks like it's, again, we're going on the increasing measure. It looks like it's 102. And so then that's the measure of arc CR. Okay. So now we're going to measure angle CAR and see if we can notice anything. As I'm measuring this, again, this is nice because this ray is coming out and it looks like this is 50, could be 51, could be 52. It's kind of like in between. Let's say 51 degrees. So is there any relationship between 51 and 102? Well, yeah, if we double it, right? 51 times 2 is 102. Well, let's just try again. So construct a circle of your own. I'm going to mark the center. Oh boy. Again, I'm drawing something fairly large so that I don't have to it's just easier to work with. Okay, so this is my center. Then I'm going to go ahead and draw a central angle. Why don't I draw something that's a little bit smaller? So again, I'm using my straight edge here, making everything really nice. All right, this is going to be my intercepted arc, this arc right here. And again, I'm going to highlight that. So now we're going to make an inscribed angle at this arc. And just to kind of give you a bit of a different flavor here, I'm not going to put the vertex of my inscribed angle over here. I'm just going to like literally pick a spot here. And this is going to be where my inscribed angle is going to be. So again, I'm going to use my straight edge. And all right, so again, this is my central angle. vertex is on the center. This is my inscribed angle. So let's go ahead and measure the central angle, which is going to give us the measure of the arc. And it looks like it's 30. Let's look at like it's exactly 35 degrees. So again, the measure of this arc is that measure. So let's go ahead and measure this inscribed angle here. And it looks like so 15, 16, 17 and a half. All right, well, let's again, is 17.5 times 2 35? Why, yes, it is. So there we go. That is our conjecture. I'm going to go ahead and write that on the next page. This is called the inscribed angles conjecture. So the measure of an inscribed angle. So the inscribed angle is half the measure of the intercepted arc. So now let's use this in this example. So we know that the measure of arc XM, X to M is 80 degrees. So what is that going to give us here? So the first question is, what is the measure of angle X and M? So here it is. Now again, remember how I told you to find the intercepted arc of an angle, you put your fingers on the vertex and go toward the outside of the circle, toward the circle? Well, the opposite is true. So put your finger on X and put your finger on M and trace it back to find that vertex. So this angle here is half of 80. So this angle here is 40 degrees. What is the measure of arc XN? So X to N is this arc here. Well, I noticed that segment XN passes through O, so that makes it a diameter. So that makes this a semicircle. So that is 180 degrees. Normally, again, I name my semicircles with an additional point, but sometimes you don't have to. And so then what that makes also this other arc, right? That makes that 180 degrees. So then the question is, what is the measure of arc MN? Well, the whole thing is 180 minus 80. Arc MN is 100 degrees. So there you go. That is our first conjecture, the inscribed angle conjecture. And this conjecture is really important. It is going to lay the foundation for the rest of the investigations in this lesson.